This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today's discussion centers around a fascinating educational tool, a JavaScript simulation modeling the trajectory of bombs released from an airplane. It's part of a larger open source project, and it's surprisingly insightful.
Indeed. The simulation offers a powerful way to visualize complex physics principles in an engaging and interactive manner. It's not just about bombs, it's about understanding projectile motion.
Exactly. It's a great example of how technology can enhance learning. But beyond the visual appeal, what are the key educational benefits?
The interactive nature allows students to experiment with variables like initial height and observe the immediate impact on the trajectory. This hands-on approach fosters a deeper understanding than passive learning.
And the simulation isn't isolated, it's part of a broader collection of resources. How does this fit into the larger educational ecosystem?
The simulation is part of the Open Educational Resources/Open Source Physics at Singapore project, a vast collection of interactive physics simulations. This context provides a rich learning environment, allowing students to explore various physics concepts.
So it's not just about projectile motion, it's about integrating this specific simulation into a broader curriculum. What are some of the key features that make this simulation effective?
The adjustable parameters are crucial. Students can change the airplane's initial height, observe the resulting trajectory, and understand the relationship between initial conditions and the projectile's path. The control panel, play/pause, step, and reset functions further enhance the learning experience.
The simulation is built using HTML5 and JavaScript. What are the implications of this technological choice for accessibility and usability?
The use of HTML5 and JavaScript makes the simulation readily accessible on most modern web browsers without requiring any plugins. This broadens its reach and eliminates barriers to entry for students.
That's a significant advantage. The document also mentions the Creative Commons license. How does this impact the simulation's use and distribution?
The Creative Commons Attribution Share Alike 4.0 Singapore license allows for broad sharing and adaptation, promoting collaboration and wider adoption within the educational community. However, commercial use of the underlying library requires separate licensing.
The document mentions sample learning goals and a for-teachers section. What kind of support is provided for educators using this simulation?
While the specific learning goals aren't detailed in the provided text, the existence of such a section suggests that the creators intend for the simulation to be used to teach specific concepts related to projectile motion and kinematics. The For Teachers section likely provides supplementary materials, lesson plans, or guidance for integrating the simulation into classroom activities.
That's important. Effective educational tools need to support both the student and the teacher. What about the quiz and essay questions included in the document? How do they contribute to the learning process?
The quiz and essay questions provide opportunities for assessment and deeper engagement with the concepts. They encourage students to reflect on what they've learned through the simulation and apply their understanding to solve problems and analyze scenarios.
The document also acknowledges some limitations and suggests potential improvements. What are some areas where the simulation could be enhanced?
A more detailed specification of the intended learning goals would improve its effectiveness. A clearer description of the adjustable parameters and their effects would enhance usability. Furthermore, incorporating more realistic factors, such as air resistance, could make the simulation even more valuable.
The simulation models the trajectory of bombs. How does this seemingly specific application translate to broader applications in physics education?
While the context is bombs, the underlying physics principles are universal. The simulation effectively demonstrates projectile motion, a fundamental concept applicable to numerous real-world scenarios, from sports to rocket science. The specific context can spark student interest and provide a relatable example.
The document mentions integration with the Singapore Student Learning Space, SLS. What are the benefits of such integration?
Integration with SLS provides a seamless learning experience, allowing students to access the simulation within their existing learning environment. It also facilitates data tracking and assessment, providing valuable insights into student learning and progress.
The document mentions the use of AI tools like GPT and Claude in the creation of related simulations. How is AI impacting the development of educational resources?
AI tools are revolutionizing the creation of educational content. They consist in generating text, creating interactive elements, and personalizing the learning experience. This allows for faster development and potentially more engaging and effective simulations.
What are some potential future directions for this simulation and similar projects?
Future development could include incorporating more realistic factors such as air resistance and wind, creating more complex scenarios, and developing adaptive learning features that personalize the experience based on student performance.
How does this type of interactive simulation compare to traditional methods of teaching physics, such as textbooks and laboratory experiments?
The interactive simulations offer several advantages. They provide immediate feedback, allow for experimentation without the constraints of a physical lab, and can visualize complex concepts in a way that textbooks often cannot. However, traditional methods still hold value, particularly hands-on laboratory work that develops practical skills. A blended approach combining simulations with traditional methods is often the most effective.
Could you outline a potential lesson plan incorporating this simulation?
A lesson could begin with an introduction to projectile motion concepts. Students could then use the simulation to explore the effects of changing initial height and observe the resulting changes in trajectory. Following the simulation, students could work through the quiz and essay questions, reinforcing their understanding and applying their knowledge. Finally, a class discussion could address the limitations of the simulation and explore real-world applications.
This document lists numerous related simulations. What is the overall impact of this extensive collection of resources?
The large collection of simulations provides a comprehensive and interconnected learning experience covering a wide range of physics topics. This allows students to explore different concepts and build a strong foundation in physics. The interconnectedness of the resources allows for a more holistic understanding of the subject.
What are some of the other notable simulations mentioned in the document?
The document mentions simulations covering topics such as inelastic collisions, falling rods, and various wave phenomena. The diversity of simulations caters to a wide range of learning styles and interests.
Let's address some specific questions from the document's FAQ section. The first question asks, what is the trajectory of bombs released from airplane JavaScript simulation Applet HTML5?
It's an interactive web-based simulation designed to help users understand the kinematics involved in projectile motion, specifically the trajectory of bombs released from an airplane. It allows users to manipulate variables and observe the resulting changes in the bomb's path.
The next question asks about accessibility and embedding the simulation.
The simulation is accessible through a web browser using the provided embed link, iframe. It can be embedded into other web pages using the provided iframe code.
The FAQ also addresses licensing. Can you clarify the licensing terms for the simulation?
The content is licensed under the Creative Commons Attribution Share Alike 4.0 Singapore license. This allows for broad sharing and adaptation. However, commercial use of the underlying easy JavaScript simulations library requires separate licensing, as detailed in the provided link.
This highlights the importance of understanding the licensing implications when using open source educational resources. What are some of the key considerations for educators when using this simulation?
Educators should ensure they understand and comply with the licensing terms. They should also consider the learning objectives, integrate the simulation effectively into their lesson plans, and assess student learning using appropriate methods.
In summary, this JavaScript simulation offers a valuable tool for teaching projectile motion, integrating seamlessly into a broader collection of open source resources. Its interactive nature and accessibility make it a powerful addition to physics education.
Absolutely. The simulation's success lies in its ability to bridge the gap between abstract concepts and tangible, interactive experiences. It's a testament to the power of open source collaboration in enhancing education.
That was a great discussion. Thank you.